The governing factors of this design were the long span, dimensional constraints, and desired accelerated bridge construction. When looking at the factors that affect deflection, we can identify that load, length, modulus of elasticity, and moment of inertia all contribute. The only one of these factors we can modify is the moment of inertia. In efforts to develop a large moment of inertia, the following cross-sections were utilized. Notice how the bottom member is a solid 1 by 1 inch section, which greatly increases this value. This design utilizes the entire bridge envelope as the section is nearly 22 inches deep. To aid in accelerated bridge construction, the members were consolidated as much as possible while also complying with the dimensional constraints for each member. You can see the member in red that connects all longitudinal members of the bridge, which is intended to decrease trips to the staging zone and locations where bolts must be inserted. Our design team has considered all of the governing factors to deliver the best possible bridge for the San Diego National Wildlife Refuge.
The analysis was performed using the analysis software SAP 2000. Hand calculations were performed using a simplified structural model with the double integration method utilized to calculate deflection. Calculations for member buckling were also produced. Each stringer was assumed to be a beam in the elastic state under all loading. This led to the agreement that the software was producing accurate results. The part drawings were modeled using the Autodesk Inventor software. This allowed the design team to ensure accurate dimensions on both connections and sections. The bolt holes were assumed to be 1/16 inch larger than the bolt diameter of 3/8 inch. After substantial design of the stringers was complete, placement of lateral bracing was considered. Once fabricated, the lateral design was finalized by completing multiple tests on the bridge.
The small-scale model was fabricated from steel sections delivered in 20-foot pieces. A miter saw was used to cut steel sections to the correct dimension. Using a TIG welder, the manufactured connections were welded into the cut sections. The entire stringer was laid out on a jig table to ensure the accuracy of measurements and welds. The entire fabrication process is expected to take 4 months from January 1st to April 15th. As the owner, you can be assured that our fabrication processes are of the highest quality and precision.
We have a talented group of young professionals prepared to construct this bridge. Our goal at Iowa State was to minimize construction time, which will be accomplished by using 6 builders. One major constraint identified by the plan set is the 7-foot wide river. This makes it very difficult to construct over, as most equipment does not reach that far. We are confident that we have the equipment necessary to work alongside the river while keeping safety in mind. We have utilized long sections in the middle that can be constructed near the banks of the river rather than in the center. The bridge will be constructed from the abutment towards the river using segmental construction. You can see the member in red that connects all longitudinal members of the bridge. This will help the construction crew to ensure a quality build without missing any bolts. The yellow members will be constructed along with the red first so that the structure will stand without temporary supports. When both stringers are constructed, the blue and green members will be added for increased flexural rigidity. We want to ensure that you, the owner, have a quality bridge in a timely manner. Through these construction practices and multiple years of experience, we are confident in our ability to deliver such project.
The AISC Steel Bridge Club from Iowa State University is proud to present the bridge to the San Diego Wildlife Refuge. Go Cyclones!